Okay, girls, so we're going to start our chapter 4.7, which is dividing rational numbers. So to divide rational numbers, we have to remember that division is the opposite operation of multiplication. I'm going to start first by the steps. Some of you might have learned this in primary school. If you haven't, this is the way that we're going to do it. So you're going to remember it by stay, change, and flip. So I'm going to do some examples to explain how this algorithm works. And I'm also going to do some diagrams to show you what is being represented when we are dividing fractions. So let's start by doing this example. Okay, so example 1. We're going to do 4 divided by 1/3. So to do this, first we have to remember that how do we write 4 as a fraction? So we write it as 4 over 1. Okay, divided by 1/3. Now we're going to use the algorithm that I have there. So stay. By stay, what do we mean? I'm going to have here. Stay means that the first fraction is going to stay exactly the same. The second part says change. Change means that we're going to change our division sign. And then flip. Flip means that we are going to flip our second fraction. So let's do those steps in order. So stay. First fraction stays. Change. My sign change to multiplication. Change to the opposite. And then flip. I need to flip my second fraction. And now how do we do this? 4 times 3 over 1 times 1, which is going to be equal to 12. 12 over 1, that is the same as 12. Now let's look at what we're representing here. So we can think that I have, let's say, 4 why is that happening? Okay, 4 cakes, let's say. So 1, 2, 3, and 4 cakes here. And I have to divide each cake into 3 pieces. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, now the question is, how many pieces do I have in total when I have that 4 cakes divided into 3 pieces, or into 1/3? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 pieces. That's my answer. Let's do another example. So example number 2. So it's going to be 1/3 divided by 1/6. Okay, I don't remember what colors I used. Purple, blue, green. So purple, stay, blue, change, green, flip. Okay, so let's do this. 1/3 stays. My operation changes to the opposite, so stay, change, flip, and my second fraction flips. Now let's write this as 1 times 6 over 3 times 1. And notice what I told you in the previous video, that I can do a simplification here because I have a 6 on top and a 3 on the bottom. So I can divide this one by 3 and divide this one by 3, which is cancellation. So I'm going to do 6 divided by 3 is 2. This one, 1. So my answer is going to be 1 times 2, which is 2, over 1 times 1, which is the same 2. So let's look at what this represents. So if I have one whole that I'm going to divide into 3 pieces because I have 1/3 here. Good. And let's color. Where is it? Let's color 1/3. Perfect. Now, if I have to divide this 1/3 divided by 1/6, so what I'm going to do is, how can I change 1/6? What is it going to be? 1/6 is here because I have now 6 pieces, agree? So I have 6 pieces here. Now let's think, which means that these little squares represent 1/6. How many times does 1/6 fit into 1/3? So this square here is 1/6. How many times this green square fits into 1/3? Twice, which is the same answer that I got here, 2. Okay, let's do one last example. Okay, so our third example is going to be, I have 2/3 divided by 4/9. So stay, 2/3, change, multiplication, flip, 9/4. It's going to be equal to 2 times 9 divided 3 times 4. Now, this 9 with this 3 I can cancel, divided by 3, this one becomes 3, divided by 3, this one becomes 1. And 2 and 4 I can cancel, so I can do 2 divided by 2 is 1, 4 divided by 2 is 2. So my answer is going to be 1 times 3, which is 3, over 1 times 2, which is 2. And then I have, this is an improper fraction, so I have to write it as a mixed number. It's going to be 1.5. Fantastic. So that's the last example that we're going to do for this section.